Hi students, welcome to another video of Smartly Learn. In this video, let's see how to solve the ninth question in exercise 10.3. Is the function f of x defined here continuous at x is equal to 0? What about its continuity at x equal to 1 and x is equal to 2? So first let's make a note of the function that's given to us. So here f of x is defined as 2x squared minus 3 when x is less than or equal to 1 and it is equal to 5 when x is greater than 1. Now we are going to test the function's continuity at 3 points. X is equal to 0, x is equal to 1 and x is equal to 2. So let's write down the test for continuity, which means limit x tends to 0 plus f of x should be equal to, so in this case I'm writing it generally a plus, so this should be equal to limit x tends to a minus f of x should be equal to f of a, where a being the point at which we are testing the continuity. So let's start with the first one. So in this case we are testing the continuity at x is equal to 0. So the first thing that we will do is we are going to check out limit x tends to 0 plus of f of x. We are going to check out the limit x tends to 0 minus of f of x, and finally we are going to compute f of 0. So if all the three are equal, then we will declare that x is equal to 0 is continuous. So let's start with the easier one. F of 0 means wherever there is 0, I'm going to just put x, there is going to be 0. Since the function is defined for x less than 1 as 2x square minus 3, so here wherever I encounter x, I'm going to put 0. So 2 into 0 cube minus 3. So this is simply 0. So the answer is minus 3. Let's mark it. Now limit x tends to 0 minus f of x. In this case also, if you move in the negative direction to reach 0, this is the place where you're going to arrive at. So here is again, I'm going to put 2 into 0 cube minus 3, the same expression. So the same answer, minus 3. Even if you move from the positive direction of x and reach 0, it is going to be still to this particular function. So 2 into 0 cube minus 3. So the same answer, minus 3. So the function is definitely continuous at x is equal to 0. Now let's repeat the whole process for the function at x is equal to 1. So in this case, you are going to compute limit x tends to 1 plus f of x. You are going to compute limit x tends to 1 minus of f of x. And finally, you are going to compute f of 1. Now, according to the definition, when x is less than or equal to 1, this is my definition. So, in I compute f of 1, it is 2 into 1 cube minus 3. So, 2 into 1 is 2, 2 minus 3 is minus 1. Now, when I compute what is limit x tends to 1 from the negative direction, my definition is still this. So here it is 2 is going to be into 2 into 1 cube minus 3. So again, I'm going to get a minus 1. However, when x is greater than 1, my definition is x is going to be equal to 5. So here when I say x tends to 1 plus, it's moving from the positive direction. So here the value of f of x is going to be 5. So you see that all the three values are not continuous. Therefore, at the point x is equal to 1, this function is not continuous. Now let's repeat the whole process when x is equal to 2. So here what are we going to compute? F of 2. So when x greater than 1, f of 2's value is 5. So directly return it as 5. Similarly, if limit x tends to 2 plus f of x, will also be simply 5 because that is how the definition is given, and limit x tends to 2 minus f of x is also going to be equal to 5 because according to x greater than 1 definition, its value is 5. So we see that the value in all these cases are 5. Therefore, at x is equal to 2, the function is continuous. So please close the answer as function is continuous at points x is equal to 0 and x is equal to 2 and not continuous at x is equal to 1. In the next video, we will see how to solve the 10th question in this exercise. Please extend your support to me by subscribing to my channel Smartly Learn. You can also reach out to me through my website www.smartlylearn.in for more practice worksheets. Thank you. See you in the next video. Bye.